Hey guys, welcome back to my channel. My name is Ash, and today I'm gonna derive the cosine rule. Okay, now the cosine rule is a pretty, you know, is a pretty good theorem. It's very useful, especially in Olympiad geometry. But if you're a JE student, I'm gonna tell you this: you have nothing to worry about. Okay, so suppose you've got a triangle. Let's say it's this. Okay, let's make it a bit somewhat like pretty bad at drawing. Okay, somewhat like this. A B C. Let's call this theta. Let's call this A. Let's call this B. Let's call this C. Okay. Now the cosine rule states that cos of theta is a square plus b square minus c square by 2ab. Pretty simple, right? It's just this. Just add the square of this, add the square of this, add the square of the adjacent side, subtract the square of the adjacent side, and just multiply this by 2 and take it down. Okay. You'll get a hang of it pretty fast. Okay. This is the formula, and I'm gonna derive that along with the sine rule. Okay. I'm also going to derive this sine rule. We'll get to that later. Now the derivation of the cosine rule is very, very, very simple. Yeah, you might be like, wait, Darsh, how did I get the square here? How did I get the square? How did I get this? This all seems very complicated. No, it's actually not complicated at all. It'll be very basic, like what you've studied in class 10. Okay, so let's go through this. Suppose you have a triangle like this. Okay, not getting this. Okay, suppose. Okay, let's make this a bit bigger. Suppose you have a triangle like this, ABC, and suppose we are not going to directly go into trigonometry. Let's name the sides A, C, and B. Okay. Now, you know, the derivation would be somewhat like this. Someone just dropped a random perpendicular. That's it. After that, it's just two or three concepts mixed. Okay. So what I'm going to do is I'm going to drop a perpendicular like this. Let's call its height be h. Let's call this side x. Okay, this side, and this is a minus of x, of course. So a minus x. So now it's almost over. Just apply basic Pythagoras here. X squared plus a minus x squared equal to c squared, equation 1. Pythagoras in this triangle, and h squared plus x squared equal to b squared. Now you might be like, okay, that's I understand it. You take the x square out of this, you subtract this, and you get something because both of these get cancelled. Actually, this is where it's a step that's kind of magical because I'm asking you to add both of these. So it's equation 2, and I'm telling you to add both of these. Now you just add both of these. Now if you add both of these, you get 2h squared plus, if you expand this, you get 2x squared plus a squared plus minus 2ax equal to c squared plus b squared. B squared, that's it. Now I'll just expand this. I'll just make this a bit more cleaner. 2 times h squared plus x squared plus a squared minus 2ax equal to b squared plus c squared. Now we don't want this. This is not needed, but the question is, it's pretty easy to eliminate because see, this is just b squared, right? That is just b squared. So 2b squared plus a squared minus 2ax equal to b squared plus c squared. To eliminate this, here you get a square plus b square minus c square equal to 2ax. Now, if you notice here, let's call this angle theta. Then what's cos theta? Cos theta is basically, wait. Okay, let's go here. Let's call this angle theta. Then what's cos theta? Let's just erase this. What's cos theta? Basically, cos theta is x by b. Now you get x is b cos theta. Apply that here. X equals to 3. That here you get a square plus b square minus c square equal to 2ab cos theta. Now, this is basically the cosine rule, or you can just bring it down to a better form. Cos theta is a square plus b square minus c square by 2ab. And we are done. Okay, so this is one of the most important formulas in trigonometry, cosine rule. The next one is a bit more important than the cosine rule because it's gonna be used a bit more. Okay, you can. I'll tell you why this is powerful because see, if you get any triangle in the world, if you know the length of its sides, you can pretty much figure it out, figure the angles out. Okay, suppose R is 2, 1, 2, 3, yes, 1, 2, 3, I can think that's possible. Okay, let's call this 1, 3, 5. I can pretty much find out this angle. I'll get cos theta is 1 square plus 3 square minus 5 square by 6, which is just 10 minus 25 by 6. It's minus 15 by 6 minus 5 minus 2. Okay, that's just minus 5 by 2. Okay, I think there's been some mistake. That's 10 minus 25, 15 by 6. 5 by 2. That's almost 2.5, yeah. So cos theta. Okay, I guess there's some configuration issues. We'll deal with that later, but now let's move on to the next rule, sine rule. Okay, now the sine rule is pretty much as important as the cosine rule. Now, what's the sine rule? The sine rule says if you've got a triangle somewhat like this, okay, let me just do that once more. Okay, let's say you've got a triangle ABC. We'll label this as before ABC cos theta. Now it says that, let's say this is alpha, this is gamma. Okay, this is beta. And it says that theta by A, no, wait. A by sine theta equal to B by sine alpha equal to C by sine beta equal to 2R. You might be like, okay, how is that useful? Well, that's pretty useful. Okay, that's pretty useful. Um, it's useful in many ways. If you've given the radius, you just given one angle, you can find out the sides. Okay, it's pretty useful. Now, the derivation is pretty easy, honestly speaking. Okay, it's pretty darn easy. Wait just a second. Derivation. Okay, now how do you derive this? Derivation. Suppose you've got a triangle. Now, what you do is it's pretty clever. You draw a circle. Now, mind you, this is not a circle. You assume this point to be the center, okay? You assume this point to be the center, and or else you can. Okay, wait. We'll try one more way. I guess I took a lot of month. So we could do one thing, okay? Instead of reconstruction, just draw a simple triangle and wait, and you draw its circumcircle, somewhat like this. Okay, okay, somewhat like that. That'll do. Now you mark its circumcenter, basically the center of the circle. Let's call this A, let's call this B, let's call this C, let's call this A, let's call this B, let's call this C. Okay, I'll join this. Let's call this theta. And this is 2 theta. What I'm going to do is I'm going to actually drop a perpendicular here. Let's call this theta. Let's call this theta. Okay, I'll call this center O. Now we know that this is R. We know that this is R. R is the circumference. So we know that um, let's see, this is A by 2. This part. Wait just a second. So I can now relabel this. Since this is the radius, blah blah blah, you know that this is A by 2. This is A by 2. So we can actually do sine theta here, and you get sine theta is A by 2R. So you get 2R is A by sine theta. Now, uh, we could do this similarly for the other sides, and you'd get a similar result equal to B by sine. Let's call this alpha. Let's call this beta. Sine A by B by sine alpha, C by sine beta. And this is basically the sine rule. Okay, so we are done. It was that simple. I made it a bit more, lengthy, the video, because I actually needed to explain this to you. But this should take 10 minutes, both of these, okay, for you to derive them. It's not pretty complicated derivation in my opinion. Okay, it's pretty easy. So yeah, you should try deriving this on your own first. Okay, I don't like the way this is taught. Uh, this is, this is very logical. If someone tells you about the sine rule, uh, You can just think of it. Just draw the circumradius, do everything yourself. Okay, yeah. So that was it for today's video. I hope you enjoyed it. Do make sure to leave your feedback in the comment section. As always, bye.